All right, this is for 8.4 solving systems using multiplication first. So this is a little different than we've done before, where we can just add the equations and something eliminates. So if it was something like, if it was 2x plus 3y equals 10, and then we had a negative 2x plus y is equal to 2, and then when we add them together, the two x's will cancel out, the variable x cancels out. We're left with 4y equals 12 because you add left side to left side, right side to right side, combine like terms, and we can finish solving from there. So those are the kind that we've done before. And then if they didn't cancel out, so say that didn't happen, say that it was just 2x plus 3y equals 10, and then 2x minus y was equal to negative 2. So that's when we took one of the equations and we multiplied by negative 1. So if we took that bottom equation and multiplied it by negative 1, and then we would get negative 2x plus y, because that'd be negative 1 times negative y, is equal to a positive 2. Then we could add those two equations together and something would eliminate. So those are the types that we've dealt with so far. So our question now is, well, what happens when it's not that nice at all? So I've got this example. I'm just going to skip, I've got a completed example here, but I'm going to go ahead and go to the example 1. So if you notice in example 1, if we add these two equations together right now, nothing's going to eliminate. And even if we multiply one of them by negative 1, nothing's going to eliminate. But what would be really nice is if this number right here wasn't a negative 1, because remember there's a 1 right there, it'd be nice if it was negative 2, because then 2x plus a negative 2x would cancel out, or would eliminate. So what we can do is, remember, what we do to one side, we must do to the other. So let's just go back up here and fill that out real quick. So in our notes, this was just a reminder, what we do to one side, we must do to the other. Okay, and we can do whatever we want as long as we do it to both sides. And when we multiply and divide, it has to be by every term. Okay, so if we go back down here, again, I can do whatever I want. So I can actually take this second equation and multiply it by 2. So distribute, 2 times negative x is negative 2x, 2 times 3y is a positive 6y, and then on the other side, 2 times 7 is 14. So that's my new equation number 2, and I can add that to my equation number 1. So I'm going to copy down equation number 1 underneath here. And now something will eliminate. So remember, we don't want to add them together unless something eliminates. Well, now that we multiply by 2, these are the same equation still. They just look a little different because we doubled it. So now we're going to add that equation 2 to equation 1, and something will eliminate. So the negative 2x and 2x, you add that together and eliminates, because remember, we're adding right side to right side, left side to left side. 6y plus 5y is 11y, and then 14 plus 8 is 22. And now look, we only have one variable in this equation, and we can finish solving. And the rest of the solving is the same as we did with substitution and with elimination before. So divide by 11, so we get y is equal to 2. Box it up, and then you get to choose an equation to solve for the second variable. So, but remember that you don't ever want to use this one that you multiplied by something. Never, never, never. You always go back to one of the originals. So let's go with equation number 1. How about? So then it would be 2x plus 5. Instead of y, we write not negative 2. We write 2 because that's what 2 is equal to, or y is equal to 8. Then you just finish solving. So 5 times 2 is 10, is equal to 8. Minus 10 from both sides. That zeroes out, so you get 2x is equal to negative 2. Divide by 2, and x is equal to negative 1. All right, now we check our answer just like before, since we already used equation 1. This is not working with me. Equation 1 to solve for the second variable, we're going to check it in equation number 2. So check, so in equation number 2, it is negative of our x, so it's a negative of a negative 1, so be careful there. The negative This negative is written once because it's there, and then we write another negative because of the negative in x, what x is equal to, plus 3 times our y, which is 2. Is that really equal to 7? So this right here is like the opposite of -1, which is a positive 1, or a negative times a -1 is a positive 1, plus 3 times 2, which is 6, and 1 plus 6 is 7. Final answer, -1, 2, so written as a coordinate point. So after that first step, after you multiply by something, some number, so that one of the variables eliminates, then all you have to do is add it and then finish the problem from there. So it's really similar to what we've been doing. It's just one extra step. So let's go back and fill in these notes here. So step 1, we want to multiply one or both equations. So we'll have an example where we have to do both. So that the coefficients, so remember coefficients is the number in front of the variable, like 2x, 2 is the coefficient, except that one is positive and one is negative. And then you add the equations to eliminate, and then we solve like normal. Okay, so let's do one more example, and then I'll do an example where we have to do both of them. Okay, so for example 2, we're going to solve using elimination. Notice that right now if we add the equations together, neither of the variables eliminates. So we need to multiply by something first. So you got to think, which variable do I want to eliminate? Because you can eliminate either of them. However, in this one is easier than the other. So it's not really easy to multiply by something to get to 2. Multiply 3 to get to 2. It's a fraction, 2/3, but that's kind of hard. So we don't really want to do that. But look at 2. I can get 2 to match 6 really easily by multiplying by 3. But I want to multiply by a -3 so that I'll get a -6y and a positive 6y, and they will eliminate. So I'm going to take that top equation, so equation number 1, and I'm going to multiply it by -3. Both sides and everything. So we're going to distribute here. -3 times 3x gives us -9x. -3 times 2y gives us -6y, equal to 6 times -3 is -18. Okay, so now I've got, that is my new equation number 1. And now when I add it to equation number 2, something is going to eliminate. So these y's will eliminate, okay? So let's add left side to left side, right side to right side. So combine like terms. So I can combine 2x and a -9x is -7x. And then our 6y and -6y eliminate, equals -17 plus a -18 is a -35. And now we have one variable and we can finish solving. So divide each side by -7 and you get x is equal to 5. All right, you can pick either equation. Again, don't use this one because we could have made a mistake. Also, it's bigger numbers, so why would you want to use it anyway? Always go back to the original. So let's go ahead and go with equation 1. So in equation 1, 3 times our 5 plus 2 times y, which we don't know, is equal to 6. We just finished solving. So 3 times 5 is 15, plus 2y equals 6. Subtract 15 from both sides. Zeroes out on this side, so we're left with 2y is equal to -9. And you will notice we're going to get a decimal, but that's okay. Divide by 2. So you can leave it as -9/2, or you can write it as -4.5. The only time I don't want you to write it as a decimal is if it's a repeating decimal. Then you need to leave it as a fraction. Okay, so now we need to check our answer. So we're going to check it in equation number 2, since we found our answer in equation number 1. So we have 2 times our x, which is 5, and then plus 6 times our y, which is -4.5. Is that really equal to -17? Okay, so just evaluate. 2 times 5 is 10. 6 times -4.5. 6 times 4 is 24. 6 times a half is 3. So it'd be 27, but it's -27 since it was -4.5. And then 10 plus a -27 is a -17. So our answer is correct. And we write our final answer as a coordinate point which is 5, negative 4.5. So that's where those two lines intersect. Okay, last example here, example 3, is a little different. Okay, example 3. Notice that if we add them together right now, nothing will eliminate. And so we get to choose if we want to eliminate x or y. So what number would we multiply 3 by to get to 5? It's not an easy number, it's 5/3. So we don't want to multiply by a fraction, so let's not do that. Even to get 5 to 3 would be multiplying by 3/5, which isn't as bad as 5/3 since 5/3 is repeating. But again, we want to avoid fractions. Okay, what do we multiply 4 by to get to 7? Again, it's a fraction, 7/4. And to multiply 7 to get to 4, you'd have to multiply by 4/7. So none of those are good options. So what do? Well, we actually have the option of multiplying them both by something. So you want to look at a number that both of the coefficients divide evenly into. So their least common multiple. So the least common multiple between 3 and 5 is 15. So I can multiply the top one by 5 and the bottom one by 3, and then I'd have matching coefficients. However, I do want one of them to be negative because I want a negative 15 to cancel out with a positive 15. So then you would get to choose. Do you want negative 5 and positive 3 or positive 5 and negative 3? But we could also do the y. So I can multiply the least common multiple of 4 and 7 is 28. So I can multiply the top by 7 and the bottom by 4. Now I would multiply them both by positive numbers because this one's already negative. So if I multiply this by 4, it'd be negative 28. This one by 7 would be positive 28. So it's really up to you. I think a lot of times you choose the one that's smaller. So that would be the 15. So I'm going to go ahead and multiply the top equation, so equation number 1. I'm going to multiply that by a negative 5. And I'm going to multiply the bottom one, the second equation, by a positive 3. Okay? So negative 5 times 3x is negative 15x. Negative 5 times 4y is a negative 20y is equal to, you'll need a calculator, 112 times a negative 5 is negative 560. So that's my new equation number 1. So that just came down here. New equation number 2, 3 times 5x is 15x. 3 times negative 7y is negative 21y equal to negative 114 times 3 is negative 342. So that's my new equation number 2. So that just came down here. All right, now when I add them together, something will eliminate. My negative 15x and my 15x added together will eliminate. Negative 20y plus a negative 21y is a negative 41y equals, and then negative 560 plus a negative 342 is negative 902. Okay, divide each side by negative 41, finish solving. So y is equal to 22. Then we get to pick one of the original equations. Again, don't use these because we could have messed them up. Also, they're bigger. So use one of the original 2 equations. I'm going to use equation 2 this time. So 5x, not y, 5x minus 7 times our y, which is 22, equals negative 114. So we need to do 7 times 22, which is 154. So it's minus 154. 5x minus 154 is equal to negative 114. We're going to add 154 to both sides. So that zeroes out on this side, leaving us with 5x equals, and then negative 114 plus 154 is 40. Divide each side by 5, and x is equal to 8. So now we need to check our equation into the first, just check our answer into the first equation since we just used the second equation. So to check our answer, be 3 times our x, which is 8, plus 4 times our y, which is 22. Is that really equal to 112? 3 times 8 is 24, plus 4 times 22 is 88, is equal to 112. And yes, 24 plus 88 is equal to 112. So our answer is correct, and we write our final answer as a coordinate point because that's where those two lines intersect. Okay, so that should be it for the examples. The rest of them, you'll either have to multiply one of them or both of them by something, so let me know if you need help.